This is a Math 990 video going over the Module 5 reality check assignment, or at least trying to help you get started. So what this assignment deals with is different ways to find the area of a figure and how that actually ties into what we're doing for the Module 5, for Module 5, the problems in Module 5. So if you look at this first figure, you can see there's the big rectangle, but then it's also broken up into smaller rectangles, or basically smaller portions broken up, okay? And so in this first section, what you're going to do is you're going to find the area of each of the rectangles, okay? So in this first part, they did 9 times 3. Well, we can see that would find the area of this greenish rectangle in the top left corner, okay? So let's go ahead and look at how we would find the area for the other figures. So if I was going to do this one right here, well, I know this length up here is 12. This height is 9, or I guess we can call it the width because of that. So for the first figure, I could say 12 times 9. Okay, and that's going to equal 108 units squared. It doesn't say what units are, but we'll just go ahead and say units squared because it's an area. Okay. Let's do this so it's a little easier to see. And then we would do similarly right here. We'd say, okay, well, we know this length is still 12. This width now, though, is going to be 3. We can see because across is 3. So we'll say, okay, 12 times 3 for that little rectangle is going to be 36 units squared. And then I will let you find the area for that last one, okay? So that's for that number 1. And okay, so once we find those 3 remaining areas, we need to find the sum of the 4 areas. So basically what we're doing is we're adding up the area for each of these small rectangles, and that gives us the total area of the big rectangle. Okay, so we just individually find each area, add them together for total area. Okay, now we're going to look at this a little bit of a different way. So we want to find the total length of the rectangle. So in this case, we're going to have 3 plus 12 for the total length, right, on top, or 15. What would the total width be? I'll let you find that one. And then we need to use L times W to find the area of the figure. So if we find out this is our length, you find the width, and then you'll find the area. And then you can answer the question, do the answers you found using method 1 and method 2 match? Here's a hint, they should match. So if you've done this correctly, they will match. Well, we're going to use the same idea for this rectangle. And you can see this one's a little bit different because now we're dealing with variables. We've got a y and a 9 and a 6 and a y. Okay, so basically this is a distance we don't know. So first we need to write an answer, an expression or numerical answer for the area of each individual rectangle. So for example, for this first rectangle, so this is method 1, so for this first rectangle right here, we can see we've got 6 times y. So that will be the first one, okay? This one we would have 9 times 6. For that rectangle, and so on. And I'm going to let you go ahead and finish that. Number 2, you need to write an expression that represents the simplified sum of these areas. So you need to add this all together. Here is a hint. Make sure you only combine like terms or your answer will be incorrect. Okay? Be careful, think carefully when you multiply this little bottom left blue square with a distance of y and y. Okay, so we're kind of doing the same thing we did on the first one. We're just finding the area of each of these rectangles and then write an expression that represents the sum. So we're adding them all together, although it won't look quite as neat as that first example problem. Okay, and then we're going to do method 2. We write an expression that represents the length of the figure. Well, in the first one, notice we said 3 plus 12, right? 3 plus 12 gave us 15. Well, in this bottom one, let's get back here. In this method 2 for the second example, we're going to do the same thing, except we now have y plus 9, right? Now, can we simplify that any further? Can we combine those together? The answer is no. So that whole length is just going to be y plus 9, and you might even want to think of it in parentheses. And then you'll do the same thing with the width. Find out what the width is of the figure and write that down. And then use this formula to find an expression that represents the area of the entire figure. And again, the answers should match. And I will be interested to hear which method you liked better. So hopefully that helped. If you're still feeling confused, feel free to do what you can on the assignment and then submit it. And I can even give you tips on your specific assignment. Good luck.